has the difference between the two currents. If these were the same, this would be 0, giving us a 0 for the magnetic field of the Earth. But they're not the same. That means that there is. How cool is that? Okay. So now, all right, rinse and repeat. Put on another little adorable baby mask. And then back to I1. Turn it on. Turn it up. And then your partner will tell you when you're back at equilibrium. Turn it off. Turn it off. And then switch it I2. Same thing. Turn it on. Turn it up. Your partner will tell you when you're back at equilibrium. Write that down as I2. Positive value. Turn it down. Turn it off. Put the third mass on. Rinse and repeat for 10 masses. 10 milligram masses. Okay, so you might have noticed that I was turning it down and turning it off after each run. Don't leave the power on, because this resistor can get very, very hot. Also, it's a good idea to turn it off, to turn the knob down, because you don't want to jar it. If you turn it on, if it's way up and you turn it on, you might jar it when you get to the higher currents, and that might disturb your equilibrium. So just gradually increase it each time. While we're on the topic, there are little holes in this power supply here. So when you're dealing with your little baby masses, be careful not to carry them over here unless they fall in, which would be bad. And last but not least, please don't get shot in the eye with this laser. It hurts badly. Okay. All right. So now, after those 10 points, we're ready to graph our 10 weights versus our 10 products of I1 and I2 to find our slope. All right, so we have this now. Let's talk about L. L is this. L is the length of the wire. We saw L already here. The length of the wire. You are given L. All right, so now let's talk about R. R is a little different. Let's see what R is first. R, once again, is this little distance at equilibrium between the centers of the wires when it's at equilibrium. We saw L already. We saw R already right here. The center to center distance at equilibrium. All right, so now, to find the equation to calculate that, seek its derivation in the appendix. But this is it. Let's see. D plus y lowercase x divided by 2 capital X, big X. All right, so D is the diameter of the wire. You are given that. Good. Let's talk about lowercase x. All right, let's see what this means. Lowercase x is the distance from the pivot, right here, to the center of the top wire. From the pivot to the center of the top wire. That's lowercase x. And, lucky you, you'll be given lowercase x. Alright, so now that leaves lowercase y. Okay, this one is a different animal. We have to measure this one. All right, to do that, we need a bigger mass. A 1 gram hulking Big Daddy mass. This one. And don't bother taking the other masses off. Leave all 10 of those there. And then just put that right on the tray. Bam. And so what that will do is it will make the wires touch. It will make the wires touch. That's what we need. So now let's look at where the laser dot is. And we're ready now to make our second line. So, since I used the top of the dot before, I'll use the top of the dot this time. And I'll make a line right at the top of the dot. Alright. Okay. So now I measure this distance with a ruler from the equilibrium line to the line where the 2 wires are touching. This distance is lowercase y. Alright, terrific. Now, all that leaves is big X. And big X is this. It's from the screen to where the laser is, all the way to the pivot. Alright, to find that, you need 2-meter sticks. Alright, so the first one, let's put it here, here. Alright. And then the second one. Here, and you're just going to have to do your best. Thankfully, since this is a much larger measurement than lowercase y, it has a better fractional error. So, just do your best. Match it up here, and I get around 120 and some change. You figure out that change, but I want to make a point that I get 120, but it's really 320.58 because I already have 1 2-meter long stick. Be careful of that. All right, so that's how we find capital X. All right, so now, once we have capital X, we can find R. And now that we have R, you can find the magnetic permeability of free space. And also, now that you have R, you can find your little bonus. You can find the component of the magnetic field in the Z direction. One thing to note, take the absolute value of this difference. We don't know which one of these would be bigger. Both of these you measure positive. Take the absolute value to make sure that the difference is positive, and then you're going to average your 10 differences to find that little bonus. Not bad for a day's work. You find a universal constant and the component of the magnetic field in the Z direction. So, last but not least, live long and prosper.